Welcome to another maths tutorial. In our previous lessons, we've explored adding fractions. In today's lesson, we are going to subtract fractions. But as always, before we begin, let's get warmed up with our 5-question brain gym. Here are your 5 questions. Pause the video and give these a go. Question 1 challenges your knowledge of mathematical language. When adding fractions, add the numerators and keep the denominators the same. For question 2, you had to calculate the equivalent fractions. We calculate equivalent fractions using multiplication or division. It's important that you remembered the golden rule. Whatever multiplication or division you carry out to the denominator, you must carry out to the numerator as well, or vice versa. Let's look at the first one. You can see that 9 has been divided by 3 to give 3. So too must you divide the numerator by 3. 3 divided by 3 will give you a numerator of 1. 3/9 is equivalent to 1/3. Similarly, we notice that the next fraction, 6/10, has had its numerator divided by 2 to give 3. This means to complete the equivalent fraction, we must divide the denominator by 2 also. 10 divided by 2 gives 5. 6/10 is equivalent to 3/5. Question 3 checks your understanding of whole parts as fractions. 7/7 is equal to 1. 1 is equal to 5/5 of a fraction. 2 wholes is equal to 14/7. You might have drawn a bar model or recognised that 14 divided by 7 is equal to 2. The next fraction is an improper fraction, 10/5. The numerator is greater than the denominator. We know that this is greater than 1 whole. To change it from an improper fraction, I divide the numerator by the denominator. 10 divided by 5 is equal to 2. You might have chosen to illustrate this using a bar model. Question 4 shows us a part-whole model. The whole fraction, or total fraction, is 6/7. One part is 2/7. What is the missing part? We need to compare the number of parts. The numerators. 6 take away 2 is equal to 4. 4/7 is the other part. Question 5, as always, is our time question. I hope you are trying to get lots of practice reading and making times throughout the day. If we look closely, we can see the minute hand is pointing past the 8. This means it is less than 20 minutes to the hour. In fact, it is 2 minutes closer to the next hour than 20 minutes to. It is 18 minutes to 7. Digital time always shows minutes past the hour. The digital time is 6:43. Now we are ready to learn. Let's get started with today's learning objective, subtracting fractions. Here we have 5/7 subtract 3/7. Thinking back to what you know about adding fractions, can you find the difference? Pause the video and have a go. Both fractions have denominators of 7. The denominator, remember, tells us what we are subtracting, in this case 7ths. Let's draw a bar model to show 5/7. To subtract 3/7, we need to remove 3 parts. Now we have reduced the number of 7ths by 3, leaving us with 2/7. Subtraction can be described as reduction. Reduction is when something is being removed or taken away. Here's one for you to do. 8/9 take away 5/9. Pause the video now and have a go. Both fractions are 9ths, so let's start by drawing a bar model. The bar model has 9 equal sections, and 8 of those are shaded, representing 8/9. We want to reduce this fraction by 5/9. We can see that we're left with 3/9. Remember, we can also represent fractions clearly on a part-whole model. Here's 8/9, which is our total. 5/9 is one part. It's the part that we want to take away. The other part of the whole fraction is the difference between 8 parts of 9 and 5 parts of 9. 8 ninths, take away 5 ninths, leaves 3 ninths. Can you find the missing numerator? Illustrate your method by using a bar model or part-whole model. Pause the video and have a go. Let's look at showing the reduction method first by representing the fraction 7/11 on a bar model. Following the reduction, we can see that there will be 2 remaining. Here I've marked that on the bar model. 5/11 have been removed to reduce 7/11 to 2/11. So our missing numerator is 5. Alternatively, we could have started with 7/11 like before and used partitioning to find the missing numerator. We would start with the whole fraction, 7/11, and then partition that into 2 parts. One part we know is 2/11, and now we can see the other part, the missing part. It is 5/11. Another way we might have illustrated this calculation is using a part-whole model. Again, the whole fraction is 7/11. We know the remainder part is 2/11, so this is one part. To find the missing part, we compare the numerators and find the difference. 7 take away 2 is equal to 5. The difference is 5/11. So our missing numerator is 5. Now let's look at 11/8 subtract 5/8. Have a look at that fraction 11/8. What type of fraction is it? And what does it tell you about 11/8? It's an improper fraction, so it is greater than 1 whole. Let's look at a bar model to show us this. The bar has been split into 8 equal sections, showing 8. I need to shade 11 sections, which means I need a second bar. 1 bar is equal to 8/8, so I need to shade 3 sections of the second bar. Now I have illustrated 11/8. I can reduce this by 5/8 to leave a remaining 6/8. Here's an example for you to try. Illustrate the calculation 13/7 subtract 6/7 using a bar model. Pause the video now and have a think. 13/7 is an improper fraction, so I know I will need more than 1 bar. Here's the first bar, split into 7 equal parts, showing 7ths. I need to shade 13/7, so I'll draw another equal size bar of 7ths so that I can shade another 6/7. Altogether, I'm showing 13/7. Now I can reduce the total by 6/7, just crossing off 6 of those sections. I'm left with 7/7. As 7/7 is equal to 1 whole bar, so too is 7/7 equal to 1. Instead of leaving my answer as a fraction, it's much better practice to write the whole number 1. Now try this example. 16/7 take away 5/7. Illustrate your approach using bar models and avoid leaving your answer as an improper fraction. Improper fractions should always be changed into a mixed number showing the whole number and fraction part, or if, like in the last example, the answer is a fraction equal to a whole number, you should give your answer as a whole number. Pause the video now and have a think. We start by illustrating the fraction 16/7 on a bar model. 1 bar shows 7/7, so we need a second bar fully shaded to represent 14/7, and a third bar with 2 sections shaded to show a total of 16/7. We start by removing 5/7 from one of the wholes. As 1 bar is equal to 7/7, this can be seen as 7/7 take away 5/7, which leaves 2/7. We now have 2/7 remaining, which together with the whole and 2/7 gives us a difference of 1 and 4/7. Pause the video and examine that calculation carefully. Do you understand why we have a mixed number as our answer? Look carefully at this equation. Notice the subtraction part is equal to the addition part. I want you to have a go at finding the missing numerator. Pause the video now and have a try. Let's use two bar models split into 11ths to compare either side of the equal sign. We always start with what we know. And in this case, we know the addition side of the equal side. We can see that 2 11ths added to 5 11ths makes a total of 7 11ths. Now we know that the left side of the equation must also be equal to 7 11ths. How many 11ths were there before the total was reduced by 3 11ths, leaving us with 7 11ths? If we use the inverse to add the 3 11ths back, we can see that there must have been a starting amount of 10 11ths. Now we've come to the end of our tutorial today. Here's a quick recap of the main points of today's lesson. 1. When fractions have the same denominator, subtract them by reducing the numerators. Do not change the denominators. 2. Remember, if your answer is an improper fraction, change it into a mixed number. A mixed number is one that shows whole part and the fraction part. 3. When balancing equations, always start with the side that you know and use bar models or illustrations to help see the problems. Now it's time for you to give your independent task a go. Remember, to learn, you need to practice, make mistakes, and then go back and read the feedback so that you learn from your mistakes. Best of luck.